Hey guys, I'm going to teach you all about scatter plots and association. By the end of this lesson, you'll be able to construct and interpret scatter plots for bivariate data to investigate patterns. So go down and get your binder, turn to the math section, and let's go ahead and take some notes. When I'm talking about bivariate data, I'm talking about two things. So in this case, two sets of numerical data like x's and y's in a table or in a graph. And it can be useful to look at these associations between those two variables because we can look for trends or patterns that allows us to make observations and predictions. A lot of the times you're going to see these associations in scatter plots. All three of these pictures are scatter plots because the points are all scattered. They do not make a straight line. If I connected the points, there would be no way to connect all of them and make a straight line. However, if the overall shape of the data resembles a line, then that association will be described as linear. So this is a linear association because the points are kind of going up. This is a linear association also because the points are going down. But on this third one, there's no association because the points are completely randomly scattered. If we can describe the shape of this association as linear, we can also kind of look at it like it's got a slope. And in this case, the slope would be positive because when we move left to right, the points are going up, kind of like balloons all flying away. In this example, there's an association between the amount of hours that are studied and what happens to your exam score. In this case, the more you study, the higher you score on a test. That makes sense. So this is a positive linear association. As the value of x increases, the value of y also increases. That's the definition for a positive association. As one goes up, so does the other one. So now let's look at the different type of association right next to that. This is a negative association. Let's see if we can figure out why. In this case, as snow cone sales increase, sweater sales aren't going up. What's happening? As I move left to right on the graph, I can see that they're decreasing. And that's what makes an association negative. As the value of x increases, the value of y decreases. It's going down as one goes up. The last type of scatter plot has no association because there's no relationship between a person's age and how many pairs of socks they own. There's no association between those two things. The change in one variable has no effect on the change in the other. So we've talked about the main types of association, positive, negative, and no association. Now is a good place to talk about causation. Causation exists between two variables when the change in one causes the change in the other. So let's look at the positive linear association here. The more hours that were studied, the higher your exam score was. This is a causation. People did better on the test because they studied more. But look at the scatter plot next to it, this negative association. As snow cone sales increased, sweater sales went down. Do you think that snow cone sales caused the sweater sales to go down? No. What do you think caused that? Yeah, probably the weather caused that. So this is an example where correlation doesn't necessarily mean causation. So we're going to look at two examples and try to decide whether we think there's an association, if so, what type of association there is, and we're going to see if there is a causation that may be causing the association to happen. In the first example, it says as the number of cars in a restaurant parking lot increases, the number of available seats inside the restaurant decrease. Is there an association there? Yes, there's a relationship between the number of cars in the parking lot and the people in the restaurant. Can you also tell me now what type of relationship is it, positive or negative, using these two definitions? There's a negative correlation or association between the number of cars in the parking lot and the people in the restaurant. As one increases, the other decreases. Is there a causation there? Yes, that's where the people in the restaurant are parking. So that means the more people are rolling up to the restaurant, the more crowded it's going to be inside and the less parking places there will be outside. The next relationship is between your height and the price of gas. It says as your height each year since birth increases, the average annual price of gas increases. What type of association is this? There's a positive association between your height and price of gas because as one increases, so does the other. But does that mean that your height caused the price of gas to increase? No. That's because this is another example of how association doesn't always mean causation. Just because there's a relationship here doesn't mean that one caused the other. All right, we're about to move on to a new definition, but before we do, let me quiz you real quick. Look at these two scatter plots, A and B. What type of relationship is shown here? You should see a positive association in both of these scatter plots. My question to you is, which one do you think has a stronger association, A or B? Take a prediction and explain your thinking. The scatter plot in B actually has a stronger association because the points are closer together and it's shaped more like a line. I've said this word a few times in this video, but the word correlation and association mean the same thing. We can describe the association or the correlation as strong or weak based on how scattered the points are. The more scattered or spread out the points are, the weaker the connection. On the other hand, the closer the points are to one another and make the shape of that line, that's whenever you're going to see a stronger linear correlation. Just like we saw in those two examples, B has a stronger linear correlation because if I drew a line connecting those points are closer to that line than they would be in A. Those points are more spread out from the line and farther away from the line than they would be in B. That's why B has a stronger correlation. You can also put correlation on a scale and define it as a number, and you're going to see that called the correlation coefficient. We usually use the variable r to represent it, and that value is going to be between -1 and 1. And that's how we measure the direction and strength of a linear scatter plot. The closer your association is to 1, the stronger the correlation. It's kind of like probability, how the closer you are to 1, the more likely something is to happen. When you start to get below 0.5 or a half, you're going to see weaker associations. When you get to 0, 0 represents no correlation at all. Then you're going to see the same thing in reverse. All that we looked at so far is positive correlations, but you can also see negative correlations just like we did up here on this graph. Again, the closer to 1, the stronger the correlation. So even if it's close to the -1, that would imply a strong correlation. So if it was -0.95, that's a strong correlation. And let's say you have a number like -0.3, that would be a negative association, obviously, because it's negative, and it's weak because it's closer to 0. The closer that the numbers are to -1 or to 1, the stronger the correlation. Okay, so let's practice looking at 4 scatter plots and 4 correlation coefficients and determine which one goes with which. The first question I'll ask you, looking at just the graphs, which one shows the strongest correlation? You should be able to determine that C has the strongest correlation because the points are closer together and closer to forming a straight line. Then my next question would be, look at these numbers. Which number is closest to 1 or -1? 0.9 is the closest to 1. So that will be the correlation coefficient for this scatter plot. Go ahead and try to match up the remaining graphs with the remaining correlation coefficients all by yourself. Press play whenever you're ready to check. All right, I just want to point out 1 or 2 things. 1, the positive correlation coefficients are like slope. They would have a positive slope. They're increasing. The next thing I want to point out is that the closer that the points are together, the higher your number is, the closer it is to 1. That's how you can see what a stronger relationship or association looks like versus a weaker one. All right, one last thing I want to talk about real quick about the graph on C. Let's pretend the orange dot was a point on this graph. So right now they're all clustered together. They have a very strong correlation. But then you have this one orange dot that's randomly out there. That point that doesn't match the rest of your data is called an outlier. It's the point that's way outside the rest of your data. It doesn't fit the pattern that you're noticing in the data or in the scatter plot. All right, guys, that's it. If you made it to the end of this video, I want to know, on a scatter plot of snacks versus energy levels, where would your favorite snack be and how energized would you feel? I know for me, there's a negative correlation between my energy level and the amount of pretzel crust pizza I eat. Today we learned all about scatter plots and associations, and now you should be able to construct and interpret scatter plots for bivariate data to investigate patterns. Go ahead and go back to the calendar now and complete any other assignments you've left for the day. If you have any questions, bye!